Hey folks, okay, we're going to do the video for 5-19 quadratic word problems. All right, let's take a look at a couple things here. Okay, so we're doing some quadratic word problems, and what we want you guys to do is to be able to work with this diagram here. This is the typical path of anything that you throw or fire or make a projectile on Earth, okay? Or for what it's worth, almost any planet where there's gravity. But, right, we want you to be able to identify these parts in a word problem and then fill them out. So, let's get started. Okay, this part here is referring to the vertex. Right? So if it asks how high it goes, we're talking about the y value of a vertex. Or k. If we're asking when it reaches that height, we're talking about the x value of a vertex or h, depending if you're dealing with vertex form. Okay, if we're asked what the initial height is, well, at the initial height, time equals 0. So we could plug in 0 for x or t, depending on what they give you. In other words, it's the y-intercept. Okay? Next, when it asks when it's 20 feet high, we have to make y equals 0. Or, y equal 20. Or h equal 20, depending on what they give you for the formula. Okay, then from there you set it equal to 0, and you have to do the quadratic formula. Or factor it. So I'm going to say solve. Okay, then here when it hits the ground, those are x-intercepts, right? So that's when y equals 0 or h equals 0. And again, we have to solve the quadratic. There we go. Okay. All right, if you need to, pause this and write this down. Okay, now, let's take a look at the first example. So we have here, it says a ball is thrown straight up into the air. The equation for the ball's height is in feet at time. Okay, so this, and time is seconds, right? That part got cut off. The equation for the ball is this. All right, so now, with that being said, okay, I have to solve for these different things here. Like I said, we just want you guys to practice that. So we want to know, for starters, what is the initial height? So what I'm going to do is I'm going to plug 0 in for t. Okay, if I plug that in, right, I'm going to get h equals 3, or 3 feet. All right, because time at the initial height is 0. All right, if it asks when it reaches the maximum height and how high it goes. So I have to find a vertex for that. I'm going to pick a different color. So now I'm going to find a vertex. So I have to do negative b over 2a. Okay, b is 40. And a is negative 16. Now, most of these come out to be decimals. It's pretty common. All right, so I'm going to plug that in the calculator. I'm going to have 4 over 2 times negative 16, which is 32. Okay, so I'm going to get 5 over 4. If you want to convert that to a decimal, you can. So the answer is, when is it going to reach the maximum height? 5 over 4, or 1.25. That should have been negative there, 1.25. Next. All right, here, how high does it go? Well, I'm going to take that and just plug it in. So I'm going to say negative 16, 1.25 squared. You could use the fraction too if you like. I'm kind of pressed for time here, so I'm going to just plug that in with the decimal. So negative 16, 1.25 squared plus 40, 1.25. Whoa, we almost had an accident here. Okay, this is why rushing is always a bad idea. Then plus 3 was 28. So we're going to be at 28 feet. Okay? Again, this is the K of the vertex. That's the H. That's all I did. Next, if let's find out when this thing's at 20 feet. So I have to set H equal to 20. So I have 20 equals negative 16t squared plus 40t plus 3. I'm going to subtract 20. So I'm going to get negative 16t squared plus 40t minus 17 equals 0. All right, now I have to do the quadratic formula. So a squared, a is negative 16, b is 40, and c is negative 17. And I have to do negative b plus or minus b squared 4ac over 2a. So I have negative 40 plus or minus 40 squared minus 4, negative 16, and negative 17. I'm squeezing in there, okay, over to negative 16. Watch your signs here. It's very easy to screw this up. All right, so now I have 40 squared, 4, negative 16, and then that was negative 17. So now I'm going to have 512. So negative 40 plus or minus. This one's going to come out kind of nice. Sometimes they don't. Negative 13. So now I have, let's see, what's the square root of 512? 16 square root 2. Okay, we're working a little backwards here. So I have negative 40 plus or minus 16 square root 2 over negative 32. Then I could reduce all those by 4. So let's see, might even be able to reduce them further. So that's negative 10 plus or minus 4 square root 2. I could reduce them all by 8 is what I could do. So that becomes negative 5 plus or minus 2 square root 2 over 4. Okay? And there is that. If you want to, you could actually kill those two negatives. Okay? That is the answer to where it is in 20 feet. Okay, last one. So now, right, we got to do when it hits the ground. Okay, so that is negative 16 t squared plus 40 t plus 3 equals 0. We're getting a little crowded here. I have to do the quadratic formula again. So this is A, B, and C. So I have negative 40 plus or minus 40 squared minus 4, negative 16, is 3, over 2, negative 16. So that's negative 32. Let's see what I get in the square root here. So that's 40 squared minus 4 times negative 16 times 3. And I got 1792. So now I'm going to do square root 1792. And I got decimal, so I got 40. Okay, 40 plus or minus. We're going to keep that to decimal since it doesn't want to simplify it. 42.33 over 32. Okay, one answer should be close to 3, right? So I'm going to do 40 minus 42.33. All right, divide by 32. And that one is no good. Never mind, I just realized we're talking about time here. Guys, let me just tell you, you might want to watch this video more than once. I understand it's long. I understand it's convoluted. Okay, 0.7. So you see the way we got a negative here? That's negative time. I'm going to take that out. Now I'm going to go back up and do this again. All right, 40 plus 42.33, then divide by 32, and I'm going to get 2.57, except for I'm missing my negatives here. Okay, guys, so that's 2.57. All right, so that's how long it takes to hit the ground. All right, guys, I know this is a bit of a lot to kind of cover in a short period of time. I tried to get this done as quickly as possible. Let's get this in here. Okay. I hope you guys found this video helpful. Again, right, you need to basically find the vertex to answer these two questions. You need to plug in t, 0 for t or 0 for x to answer what the initial height is. You need to do the quadratic formula to find out when it hits the ground. And you're going to have to do the quadratic formula to find out when it's at a specific height. Okay, guys? All right, guys.